Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Euclidean Department of Education in collaboration with Saibono Discovery Center. Today we're going to be looking at paper 2. Paper 1, we're done with it. So this time for paper 2. So I'm going to do the revision. This is the final revision for the paper that is going to be written on Monday. Now I'm going to start with looking at the topics that you're going to look at today on Monday. Now paper 2, topic spec question. In analytical geometry, you're going to have plus minus 25 marks. So the marks will range between 25, 22, 23, 24, 25. And in question 1, these are the things that you must expect in question 1. You are going to be asked about the gradients of the lines. You're also going to be asked about the equations of the straight line. So in other words, those formulae that deals with the gradients, formula that deals with the straight line, the formula that deals with the distance between the 2 points or the length of the line, the inclination, which is the angle, where they give you an angle like theta, alpha, and the midpoint of the line. So all these formulae, we need to know them and we need to understand how to use them. In question 2, you're going to be looking at the equation of the circle. In other words, the circle might be drawn for you, and then you need to find the equation of the circle. Now remember, with the equation of the circle, the x squared plus y squared equals to r squared. So a point will be given, and then you'll need to substitute the x value and the y value to get the r value. The equation of the tangent, that's where you remember that you can use the formula that the x squared plus, the x multiplied by x1 plus y multiplied by y1 equals to r squared, or you can use the y minus y1 equals to m into x minus x1. But remember that the tangent, the equation of the tangent, so it's a tangent to a circle. So in other words, you're going to have a circle in a Cartesian plane where you're having a tangent, and we'll do equation on that. You're going to be sketching an ellipse. These are 3 marks or 4 marks that you need to get. So we're going to also look at how do we sketch that. So question 1 and question 2, both these two questions are in analytical geometry, and the expected marks there will be between 25 plus minus 3. So these are marks that we must get, because there we are only use the formulae and we are sketching an ellipse. So all those formulae, we're going to look at those formulae. I'm going to show you that those formulae, and you must know this weekend you must be able to work on those formulae. This 25 marks is there for your taking. We need to know that. Question 3, 4, 5, and 6 will be on trigonometry. Trigonometry carries plus minus 50 marks. So out of the 50 marks, we expect you to get at least around 40 marks, or 35 to 40 marks. That you can get easily. In question 3, you're going to be dealing with questions that deals with calculator work. In other words, you're going to be given, you can be given angles, or you can be given those angles in radians. So you must be able to work on that. You're also going to have Pythagoras type questions, whereby you see you're given the sine of theta is 3 over 5, then get the value of determine the value of maybe tan of theta. Obviously the sine is y over r, the tan will need you to get an x, so use the theorem of Pythagoras to get the value of x, and then you can be able to, we'll do one question on that. The question 4 will deal with the reduction formula and identities. So you need to understand your identities. Some of them are there on a formula sheet, so we're going to check on it. And then you need to also deal with the reduction formula, which we are going to do just now. Question 5 will be on trig functions. I love trig functions because they're easy. We have a calculator. You just put in those values in there, and if you are requested to draw the sketch, then the Cartesian plane will be drawn for you. You don't need to draw the Cartesian plane, it's drawn for you. So you just need to check those angles, and then from there plug them into your calculator, and then you get the coordinates. Question 6 is on 3D. So 3D is also quite very easy. You need to check that the formula are there, the area rule is there, the cosine rule is there, and the sine rule is there. You just need to go and practice how and where to use the cosine rule, and how to use the sine rule, and how to use the cosine rule. Alright, these question papers are like that every year, so I don't think they'll change this year again. So in question 7, you'll have your circle geometry. So there you need to understand how to work throughout your reasons, because the problem there is the reasoning. So remember, if you don't write the correct reason, and then you get 0 mark. So the reasons must be correct. You go to your exam guideline, you check your exam guideline. There are a lot of reasons there. When you're practicing your circle geometry, your exam guideline must be next to you, so that then you learn how to write the shorthand of those formula. Those reasons. Question 8 will still be on circle geometry. Question 9 will be on proportionality and similarity. Those are quite very, 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 very easy questions that you can score marks from. So out of the 40 marks in geometry, we expect you to get around between 25 and 30, and which is possible. We can be able to get those marks. Right, question 10 will be on circles, angles, and angular movement, which is a plus minus 20 marks. There you'll have to deal with the degrees, and we have got a formula there that are so easy to use, because you are given all the values there, all the letters there are explained in this formula. I will deal with that when we go to the formula sheet. We are going to deal with the degrees and radians. We're going to deal with the length of the arc. You need to know the formula for that, the area of the sector, the length of the chord, angular velocity and circumferential velocity. Those are questions that we're going to be dealing with in question 10, so you must be able to work on that. In question 11 will be measurement, so which is 15 marks, and this I expect everyone to get plus minus 10, because then you have the area of an irregular polygon where you're going to be, the formula is there, so you'll be given that, so you need to understand how to work it out. And then the surface area and the volume, the formula for the surface area and the volume will be on the question. In question 11, if they ask you about the volume and the surface area of those regular shapes, you will be given a formula or formula for that. But those formula, sometimes you don't have to use them as they are. You need to first work out those formula, then you change them a bit so that you can be able to use them according to what you are asked in that particular question. Here's an information sheet, which is a formula sheet. So what I've done here, I've just taken out only formula that are going to be used in paper 2. But remember, the formula sheet has got all the formula, because sometimes you find that you are obliged to use the formula that we used in paper 1. So please make sure that you know the whole formula sheet. But here I've just extracted the formula that are used predominantly in paper 2. Now, the first formula there is the distance formula. Please, you must use it correctly. This is the way it's supposed to be used. So it means I'm going to have a distance here. I'm going to have the square root of. So if you say x2 minus x1, in this one you must also say y2 minus y1. Don't try to be smart and change them around. I know this, with the square it's still going to give you that, but sometimes when you have that one around, then the minus becomes a problem. Okay, now the next one is the midpoint formula. The midpoint formula must be used in that. I know some of you confuse this formula with that one. The midpoint formula is a plus sign in between. So I'm just adding. It doesn't matter if I say x2 plus x1. or y1 plus y2. It does not matter because I'm adding. The only challenge is when I'm subtracting, where I have a problem. Right, you must know even when I multiply 2 times 3 is the same as 3 times 2. But 2 divided by 3 is not the same as 3 divided by 2. So with division, it does not work. Okay, right. So in this case, you have x1 plus x2 over 2, y1 plus y2 over 2. For the gradient should be y2 minus y1 over x2 minus x1. Please go to your formula sheet and copy it correctly. In this case here, we see a lot of learners taking x2 up there and say x2 minus x1 divided by y2 minus y1. And the formula sheet is just in front of you. So please make sure that you use the formula sheet correctly. So it's y2 minus y1 over x2 minus x1. If you start with y2 there, you must start with x2. Okay, right. The next one is the inclination of the angle there. So the inclination of the line. So here we only use it when I have, for instance, if I have that, this is the x-axis, this is the straight line. So I'm going to use this formula here for angles that are formed there, or angles that are formed. You see, this is an x-axis, this is a line. So I'm going to use that angle there, or I can use that one on the other side. So I'm going to use that only when the angle is formed in the x-axis and the line, the straight line. The ellipse, easy question there. You're only going to be requested to draw or to sketch the ellipse. So the x squared here and the a squared. So for me to get the value of x, so if I've got x squared equals to a squared, for me to get a value of x so that I can put it on the Cartesian plane, because on the Cartesian plane I don't have x squared. So I'll have the square root of a squared. Obviously I'll have the square root of that. Then from there the x will be equals to a. Right? Because the square root of a squared is a. So when we do come to that question, I'll show you how we do that. Right. Now, in trigonometry, you're going to have this formula. So you're going to apply this formula. This is the cosine rule. This is the sine rule. This is the area rule. And then we have the identities, of which this one is a famous one. I call it a famous one because it's always like that. So, but now remember, with these identities, I cannot use them as they are sometimes, okay? Sometimes you can be asked here to, you can be given 1 minus sine squared theta. So it means that if I take sine squared theta to that side, I'll have 1 minus. So that for the answer there will be cos squared of theta. Sorry, there's a theta in there, there's an angle here. There's nothing like this, please. I see people sometimes when we have tan theta, you want to write it, you write it as sine over cos. There's nothing like this. There's nothing, please do not do that. So it's sine of theta over the cos of theta, depending on what the angle is given there. All right? Please, we don't want to see that. The sine without an angle or the cos without an angle, because it's a ratio. So that ratio must be with the angle. Okay. Circles, angles, and angular movement. Easy topic. That formula here, if I want to find the radius, remember, sometimes you're going to be given an angle in degrees, for instance. So you want to change that angle from degrees to radians. So for me to change this angle from degrees to radians, what do? So remember, I have a 72 multiplied by. So I want to do away with the angle. So if I want to do away with the angle, I'll divide with the angle, 180. And on top there, I put pi. If I'm given radians, for instance, 2 over 3 pi, I want to write it as degrees. So I just do that. What do I want to remove? I want to remove pi. So I'll put pi at the bottom, 180 on top, so that I can get the angle. Okay. So that question, it's 1 mark or 2 marks, please be able to do that question if it's asked. Angular velocity denoted by that letter that looks like W, it's called omega. That is the formula, and they tell you n, this n here, it's for rotational frequency, which means if I look at the question, and the question says my rotational frequency or my revolutions per minute or per second, it's given as that, so it means that the n will be the one that comes in here. The value that is given will be there. 2 pi is divided, you can just put it on a calculator and get the answer. Circumferential velocity, the other word for this sometimes I know with the examiners, peripheral velocity. So this two means the same thing. Okay, and they tell you that D stands for the diameter. So in other words, if I'm given the radius, so it means that, remember, the radius is half of a diameter. I mean, sorry, the radius is it's half of a diameter. So if I'm given a radius and I need a diameter, I must multiply that by 2. N is the rotational frequency. S there, it's equals to r theta, where r is the radius. So they tell you r is the radius. Theta is angle in radians. We see a lot of mistakes there, but when you are given that the angle of rotation is 200 degrees. Then from there you come here and write maybe the radius is 10. Then you come here and write 10 multiplied by 200 degrees. And from there you want to give us the answer there as 2000. That is incorrect. Because they say the angle is in radians. So meaning that the 200 must first be changed to radians before you substitute them there. I know that learners that do substitute with 200 at the end, then they change it to radians. But why don't you change it first and then you put it there, so that we have, because sometimes, you know, the markers might miss it and then they mark you wrong here because they want that angle to be in radians without checking that. So let's do it correctly at first, so that then we get those marks. Right. The area of the sector, you have got two formulae, this formula and that formula. So this one is when the arc length is given and you have a radius, divide by 2. This formula is when the angle is given. So can you see that that's squared here? So when the angle is given, then the r becomes r squared. But when the arc length is given, then the r becomes it's not squared. Okay, so that you must know both formula, and then you must also know how to use them anyway. Here's another formula that is a bit of a problem. Mostly learners, that 4, you omit it. Please copy it correctly so that then you are able to can substitute correctly. The h is the height of the segment. You must know what is the height of the segment on the diagram. You must know the diameter. If the radius is given, just multiply it by 2 to give you a diameter. The x is the length of the chord. So in other words, I'll have something like this with a circle. I'll have that. I'll have something like this. This one is the center. So this one here is a chord. This one here is a diameter. Okay, that is a chord, that is a diameter. But this part here and this part here will be the height of that. So this one will be the height of the segment. That part here will also be the height of the segment. Okay, so we can have that diameter there divided into 2 parts, where we have that height and the other height. So you must also learn that. Okay, when you do the questions, then you must also check this. Right. So you can see I'm spending a lot of time discussing the formula sheet because we have plus minus 17 formulae. 17 formulae that you're supposed to use in this question paper on Monday. So if you know 17 formulae and they bring about 15 formulae, then already you've got 15 marks just for writing down the formula and substituting. Okay, so you already have that 15 marks if they bring up to it. I know in most question paper, the one that I checked yesterday, it had about 15 formula. I had to use about 15 formula. So 15 formula, you get them right, you are already at 15 marks. You haven't done anything yet in terms of calculations and all that. So please, that's why I'm spending a lot of time on this. Now, remember, if the formula is wrong, then the whole thing becomes wrong. You call it a breakdown. It's a breakdown of your answer. Measurement, there you have the area there of T. You can either use this formula or that formula. Please, 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 my boys and girls, don't do a question on this formula. The instances where Elena uses, a candidate uses, that writes this formula, but then substitute into this one. And I don't understand how. So if you use this, substitute in this one. If you use this one, substitute on this one. Okay. So remember, it's M1 plus M2 plus M3 plus M to the last one, where M, and they tell you, A, it's equal parts. So I'm given a length like this. It's 20. And I'm given parts here. So in other words, an equal parts here. So what do? I must count these parts here and divide that whole, the 20 there, by this number of parts that I have in there. So that is what your value of A is. Here they said A is equal parts, so you must know that's for equal parts, okay? Then N is the number of ordinates that we are having. Okay, right. Let's look at this slide. In this slide here, I was trying to check the marks, where we can get marks, and yeah. So paper 1 is done. So I'm looking at paper 2. I was looking at 53 marks, which is translate to about 35%, but this is very low. We have done a lot this year. We've done a lot in the past 3 years for us to get up to 53 marks. I mean, that's very low. So let's check. In analytical geometry, plus minus 25, if we can get plus minus 20 marks, we are good to go. But some of them I'm going to change, like in trigonometry at 50 marks, I don't think the 12 will be, 12 is very low. So we can increase that to plus minus 25. Right, if in Euclidean geometry 40 marks, then 10 marks I think is very low, we can increase that to 15. So we've got a 20, 25, 15. Measurement is 35, maybe we can just get to 15 here. So if I calculate all these marks already, I've got 20, 45, 45 here, I've got 60, and 60 I've got 75 marks, and that's 50%. So we can be able to do that on this paper. So let's work on this weekend. Now let's get to activities. I'm not going to do a lot of activities, so I want you to pay attention on these activities that I'm going to do, because these activities are only a guide of what you're going to be having at on that paper on Monday. Now, activity 1, it's on analytical geometry. Now, when I'm doing this question, I'll also be giving the mark allocation, and you can see quadrilateral. Obviously, you need to understand quadrilaterals. You must understand which one is a square, which one is a rectangle, which one is a rhombus, which one is a kite, and all that. So those you must also go and practice that. Modules a side view of the building in the Cartesian plane. So the A point is given. So it's not 2:8, but it's 2:8, right? Right. So this is minus 2 and 8. We have minus 8 and minus 4 given at F. We have an angle which is given there. Can you see that angle is not on the x-axis and a line? It's away. So I cannot use the inclination. I cannot use tan theta equals to m. Don't. Now, and that angle here is given at 76. That angle is now between the straight line and the x-axis. You see there. But they've already given it to us. We don't need to calculate it. They say the angle, okay, I've already done that. FD, it's parallel to that. That's very important. I go to my sketch and say this is parallel to that. You see, it's not indicated on my sketch. I put it on my sketch, parallel. Now, what do I know about parallel lines? A lot of things. For instance, this angle will be equal to that angle. They are alternating angles because this line is parallel to that. Okay? Right. These two angles here and that angle here are equal to 180 degrees. The reason being they are co-interior angles. Co-interior angles. Remember, they add up to 180. So I already know. Oh, now I can see you're happy because now you can see the answer. Eh? So that's quite easy. What do I see? That line and that line are vertical. I mean, intersecting there. Okay, so these two angles are vertically opposite angles, which is 76. So how do I get that angle? This angle plus that angle will give us how much? 180. So which means that angle alpha that they're talking about here, this is alpha. Angle alpha that they're talking about here will be 180 degrees minus 76 degrees, and there will be 104 degrees. Right, so I don't need to give a reason for that. There's nothing that says I must give a reason for that. I just need to calculate it. So that angle there is 104. Right, can you see I did not use any tangent theta or alpha, it's equals to m, because that angle is not, it's far away from the x-axis. Okay. The next question states that in the same diagram, determine the length of f. Can you see now what I was talking about? The length, the distance of the line, distance between 2 points. The distance between 2 points, so then the length of the line. So here, I have this point and that point for AF. So I need the distance of that line. So how am I going to get the distance between those 2 points? Sorry. And they say you must always read what is there because it's very important. When the last mark that we're going to give there will be for that instruction. Okay, so now I'm going to have AF, it's equals to, remember, must have a square root. Okay, so now I must start, if I start with this 2 minus 2, I must also start with that 8. So I'm going to do that. So I'm going to have minus 2. There's a minus 8 here. So minus for the formula and minus for the minus 8 will give us 8 plus 8. We square that. Then we have plus. So the y, it's 8. So I don't start with this one because here I started, the x was minus 2. So the y now, it's 8 minus into minus 4 all squared. My boys and girls, please don't try to add and subtract and all that when I have something like this. Just go straight to your calculator, put the square root, open bracket, minus 2 plus 8 squared, plus the way it is, and then from there you say equals to. The calculator will go and give you an answer like that. This is already in a simplified set form. We must not stress ourselves by adding minus 2 plus 8, and then from there you write a 6, then minus 8, you say plus 4 is 12, 12 squared is 144 plus 36, and then you get 200, and then from there you need to. So don't do that. So just go to your calculator and do that. You get full marks for it. Okay, so you get full marks. Okay, now you're going to get 1 mark for that. You're going to get 1 mark for that, and that's 2 marks. So for 2 marks, you cannot have more than 5 steps. It's 2 marks. So 2 marks mean 2 or 3 steps, or even 1 step. Okay, right. Now determine the gradient of BD. So can you see the words now? Gradient. I told you in question 1, gradient. You must know that. Question 1, now we want the gradient of BD. Here is BD. BD, I need the gradient of B, but they say it must be nearest to the nearest integer. But gradient, we know the gradient. How do we get the gradient? We get a gradient by having a point here and a point there, and from there say y2 minus y1 over x2 minus x1, but I don't have anything there. I don't have anything. I'm not given. Yeah, then I have a problem. How do I solve this problem? This is one of those challenges that we have. Then from there we need to think a bit. How do I get this angle? By the tangent. Remember? Because it is between the line and the x-axis. We use the tangent. So if I use a tangent, it means of something. It means that I get a gradient, and that's what I'm talking about. So what should I get the gradient of? I must get the gradient of 76 degrees. So the tangent of 76 degrees. So the gradient times 76 is something like 4,01 But they say to the nearest integer, which means that the gradient will be 4. And that's how I get the gradient. Nice question. Please take note of this question. Take note of this question. If it comes Monday, you must be able to do it, because then even if the angle was this side, then the gradient will be, and I'm given the angle there, so I just say the tangent of this angle. Then from there, sometimes you get it as a negative or as a positive. But in this case, this one is going to be a positive gradient. That's why it's positive form. Okay. All right. 1.4 says determine the coordinates of the midpoint. Can you see these words are coming up? We cannot afford not to get these marks when we have a formula, information sheet. Right. Determine the coordinates. So coordinates means that I must write it as x and y. These are coordinates. So you can't write x equals to and y equals to. Those are not coordinates. Coordinates are in this form. Right. So meaning that I must write it in that form. So how do I get the coordinates of the midpoint? So I need the coordinates of this point somewhere here. Because if it's a midpoint, it means that that line must be equal to that. So which means I'm going to have m open bracket. So I'm going to have, remember it's this, so it's plus. So it's minus 2 plus minus 8. So it's minus 2 minus 8 over 2. Because plus minus, then it will give us a minus. Then from there, I'll have 8 minus 4 over 2. Therefore, I'll have my midpoint as, sometimes they give you point P, but in this case, they didn't give us anything, and we're just going to call this one point M. I don't have any other point M on the sketches. So now I'm going to use my calculator. So I'll get minus 5 and 2. I must go to the sketch and check if that is correct. That can be correct. Does it make sense to me? If that value there is minus 8, so that part there can be minus 5. So that can be minus 5. Here it's 0. Going up there it's 1, 2. So this point can be 2. Can you see how I can check if my answer is correct? I know that point. If I get something funny, I must know this is not going to be correct. Let's say I got minus, 2 or 5 and 2. So 5 and 2 will be somewhere on the other side. So that will not be correct. Hence, so in other words, use this thing here that I got there. Determine the equation of the perpendicular bisector. Now, perpendicular bisector is nothing else but a line, a straight line. It's a straight line, but what kind of a straight line is that? It's a line that is going to go through this, bisect this, obviously, because this is the midpoint. Perpendicular means it forms 90 degrees. That's what it means. So the perpendicular bisector is that line. It bisects this line, so bisector, and it's perpendicular, meaning that it forms 90 degrees. So I have got a point. I need the equation of this line. There are two things that I need. I need the gradient of the line, of this line, and I need this point. But my problem is that I don't have any, I only have 1 point. I cannot get a gradient with only 1 point. What should I do? I must get the gradient of that line. So the first thing that I'm going to do, I'm going to get the gradient of AF. So the gradient of AF will be 8, remember I'm starting with the y value. 8 minus 4, so it's 8 plus 4, divided by minus 2 plus 8. So if I check this, I get 12 over 6, and the gradient of that will be 2. So which means that the gradient of AF is 2. What will be the gradient of the perpendicular? That's where you, so the gradient of the perpendicular, remember, if this is 2 over 1, the gradient of the perpendicular will be minus 1 over 2. So I just swap these values and change the sign. So it's 1 over 2 with a minus. So I have the gradient of that line now. What do I need? Equation of the straight line. This question, mostly it counts 5 marks. So you listen carefully here. Then you go y minus y1 equals to m into x minus x1. So which point am I using? I'm using that point here. So I'll have y minus, the y here is 2. The gradient that I'm using is the gradient of the perpendicular bisector, which is negative half. The x1 that I'm using is this one, so it's minus and minus, I'll get a positive 5. So now, my equation here will be equals to, I know how, you know how to do this now. Y will be equals to negative half multiplied by x is this. Then I bring over the, okay, so I'll have minus 5 over 2. I bring over the 2, then the equation of that line will now be, let me just make space here, will be y equals to negative half x, and then minus a half. So that is the equation of that line here. So I have the equation of the, so it's the equation of the perpendicular bisector. Can you see that line here is a negative gradient? This one is a positive gradient. So I know I'm correct. This graph obviously is going to pass somewhere here. Sorry, it's going to pass somewhere here because this point here must be negative half. Okay, not that part, because that one is passing above the 0, which is positive. Okay, 1, I'll know the gradient of this line too. But I'm given the equation of the line MN. Where is MN? MN. What is the gradient of that line? It's minus 4 over 3. So already I know the gradient of that line is minus 4 over 3. If this is 4 over 3, the gradient of that line will also be minus 4 over 3. Because the parallel lines have got same gradient. I've answered some of the questions, you will see. Now, these ones are tangents, PQ and MN are tangents. Write down the equation of the circle. Remember, equation of the circle, I need a point. I need this point, or I need that point, any of those 2 points. So for me to write down the equation of the circle, I'll have x squared plus y squared equals to r squared. So the point that I'm using is this one. So I'll have minus 4 squared plus minus 3 squared equals to r squared. Therefore, my r squared will be equals to 16 plus 9 will be 25. So what is the equation of the circle? The equation of the circle will be my x squared plus y squared equals to 25. This is r squared. Please do not get the square root of r squared because you are going to mess up. That's why you write x squared plus y squared equals to 5. and we might give you a big 0. So please don't do that. So that equation of the circle will be that. Write down the coordinates of B. Easy. We have it every year. So this line passes through the center of the circle, going to the other part to touch the circle. So if this is -4 and -3, in the first quadrant, the B will be 4 and 3. There's nothing negative in here. Same values, we just put them there. Okay. Write down the gradient of PQ. Already I've got the answer here. The gradient of MN and the gradient of PQ are the same. So the gradient of MN is this one, -4/3, which means that the gradient of PQ will also be -4/3. Done. 1 mark, 1 mark, 2 marks. Right, so out of this question already I've got 2, 3, 4 marks. Simple, straightforward question. Right. Now 2.3 is the continuation of the same question. It says, hence, determine the equation of the tangent PQ. So equation of the tangent PQ. What do I know about this point here? It's 4 and 3. Right. To get the equation here in the form that, I'm going to use this method, which is quite easy, straightforward. You take this point, you say x times x1 plus y times y1 equals to 0, equals to r squared. So you substitute, the value of x is 3, it's 4. The value of y is 3, and that is 25. Right? So I need to get the equation of that. The equation of PQ, yes. So now I'm going to get 3y, it's equals to -4x plus 25. Right? So now how am I going to get that? So I'm going to get y equals to -4x over 3 plus 25/3. So that is the equation of PQ. That is the tangent PQ. So for me to get the equation of PQ, I need that point. So if I want to do it the other way, so I'll get the gradient of that line, and then get the gradient of that line. Then from there I substitute by 4 and 3 to get the equation of the line. Okay. All right. Now, moving right along, still on that question 2, analytical geometry. So we given this is quite interesting. Look at this. Look at this. Given the graph defined by the equation x squared over 36. So for me to get the x, I must say x squared equals to 36, and then x will be equals to square root of 36 plus minus, then which is going to give us plus minus 6. So the x will be a 6, which is somewhere here, and then -6 and 6, which are somewhere there. Now I need this one. Tricky one. But it's easy. Look at this. Y squared, it's equals to the square root of 256. First you must get the square root of 256, which is 16. 16 times 16, its square root is 256. Then I'll get y squared equals to 16. For me to get a y will be plus minus the square root of 16, which is plus minus 4. You see? So in other words, that will be a 4. The other one will be a minus 4. Then I just join these lines nicely so, without using a ruler. Then I'll have my ellipse. Then I'll get 1 mark for the points here for the x and the y. One mark for the y, 1 mark for the x, and then 1 mark for the shape, which is 3 marks. In this case, There. 3 marks is the easiest 3 marks that you can get in the whole paper. Right. Now, we're going to go to trigonometry. So you can see in analytical geometry is quite very easy. I've used the formula. I've used about 6 or 7 five formulae there. So please, let's practice there. Question 3, trigonometry. I'm not going to do a lot of those. So you are given theta there, you are given alpha. So now you need to calculate the numerical value of this. So we will have, just by substituting that value here, 32, then I have already gained a mark. Just to substitute, I've already gained a mark. Then just by going to the calculator and putting this on the calculator and then writing what the calculator gives me, I already have a mark. So I'll have 2 marks, easy 2 marks on the calculator work. On this one, just to substitute, sec squared of theta is 20 degrees minus 1, this is 32 degrees, sorry, all over tangent of 32 degrees. I already gained a mark. How easy is this? Then from there I'll go 1 over sec is an opposite of cos, right? So I'm going to use that as cos squared of 20 minus 1 all divided by the tangent of 32. Take out your calculator, punch it as it is, and you just write down your answer. I think your answer is 0,212. And you have got a mark for that, you have got a mark for changing that, you have got a mark for that. That's the easy 3 marks. Alright. Remember your sine, your cos, and your tangent. Okay, so this you must know, please. Alright. Now, these are angles. And you must know that one, it's cosec. The reciprocal of that, it's cosec. And the reciprocal of that, it's sec. The reciprocal of that, it's cot. So these are just reciprocals, okay? So in other words, cosec it's 1 over sine, sec it's 1 over cos, cot it's 1 over tangent, and the other way around. Okay, right, don't write sine theta is equals to the cosec, they're not the same, just the reciprocal of the other one. Okay, right, in the diagram below here, calculator work I've talked about. Pythagoras, this is the Pythagoras type question. Because I've got a right angle triangle, I've got an angle. I've got P that is given as 3 and M. The R value is given as, so remember this is X and Y. R is there. Can you see I've already done that? So I just need to calculate what? The numerical value of M. I don't want it as an M. So what do? Theorem of Pythagoras. X squared plus Y squared equals to R squared. You see why we call it a Pythagoras type question? Because I'm going to use the theorem of Pythagoras. So I'll have X is 3, my Y is M, my R is square root of 13 all squared. So now I'm going to get 9 plus M squared equals to 13. Remember, square root squared. If you don't understand that, put it on a calculator. Then I'm going to have my M squared equals to 13 minus 9. Transpose that. M squared is 4. M is plus minus the square root of 4, which is plus minus 2. Now, this value of Y here, it's plus minus 2. So I need to choose one of those. So the m will be equals to 2. What is my reason for ignoring the minus 2? Because in the first quadrant, m can never be negative. So that's why I chose the positive value. Okay. Right? Without the use of a calculator, same question, but now I already know that my m is 2. So for me to get 1 minus tan that, I know tangent is the y value over the x value. So in other words, it is y over x. And this thing is squared. So my y value is m, which is 2. My x value is 3. And then from there it's squared. Then I just go to my calculator. Then my calculator, I think, will give me 5 over 9. All right. So you get 1 mark for the substitution, 1 mark for that, which is 2 marks. I'm collecting some marks here, up to 75 minimum. (3.3) it says solve for x, and these are some of the questions. I know most of you get it right, but then you mess up at the end. At the start you get it right. So here, so first of all, I must take that value to the right hand side, put it as a negative. Remember, it's between 0 and 360. Please, you must check the interval. Then the tan of x will be equals to negative 0.924 divided by 2. Leave it like that. You don't have to divide it by 2 and get the values. If you want to, you can do that. But I'll prefer it like that. So I'll get the reference angle. Seeing that I've got a negative here, so it means that I need to get a reference angle. So I'll go to my calculator, shift tan, fraction button, put it as it is, negative 0.924 divided by 2. Then from there, your reference angle comes up. It is 24.796 and other decimals. Then I'll look at this. This thing here is negative. It says negative, which means where is the tan negative? In my quadrants, my tan is negative in this quadrant and that quadrant, of which here I use 180 minus. There I use 360 degrees minus, according to my reduction formula. So which means I'm going to have two answers. One of the answer will be x equals to 180 minus the reference angle. The other answer will be 360 minus the reference angle. All right. So there you go to your calculator. Then the first one will be 155.20. The other one will be 335.20. Okay, you can just put it as 202. Okay, so these are my two answers. We are going to mark that. Those answers, we are going to mark the reference angle. We're going to mark that, so you can get up to 4 marks on this question. Okay. Right, so this is theta, this is theta, this is theta. Okay, so now in this case they just say simplify into one single ratio. So for me to simplify into single ratio, I must know these two guys here. So these two guys here, the tangent and the cot. So tangent is the same as, so I'm leaving a cos outside here. The tangent is the same as sine theta over cos theta. But I know cot is a reciprocal, so meaning that it must be cos theta over sine theta. Right, so you already have 1 mark there, 1 mark there for changing those two. Then I multiply out, this cos and that cos cancels out, I'm left with sine theta. This cos here, because it's over 1 multiplied by that, it's cos squared theta. And I know the challenges that we get here is working with fractions. Multiplying out, working with fractions. Then from there, I know that this is over 1, or I can just multiply out. This is the LCM. Then I'll have sine theta times sine theta, it's sine squared of theta. Sine theta, there goes once, times that, it's cos squared of theta. I love this. I love this. I love this. Because I know on top here, sine squared theta plus cos squared theta, it's equals to 1. At the bottom, I'm left with the sine of theta. It's a single trig ratio. So once I get something that says sine theta plus cos theta or sec theta, I know there's something wrong that I've done. Okay. Now here's my favorite question. I love this question because this question, it's almost 5 to 6 marks. And easy marks, easy marks. Look at this. I'm going to write this. So here it's 180 minus, here it's 180 plus, here is 360 minus. Easy questions. We know if I've got this, it's 180 degrees. If it's 2 pi, it's 360 degrees. All right, now let's check. 180 plus, where do I get it? Here, in the third quadrant. In the third quadrant, sign is negative. But being negative and being a squared, it means that it's going to automatically be positive. So I just delete this and write sine squared of b. Then I put it inside the bracket. Simple as that. I get 1 mark for that. Cosec. 180 minus, it's in this quadrant. Sine and cosec are friends. So meaning that sine cosec is positive in this quadrant also. So I just move away there and then do that, and then from there I write cosec of b. Then I get a mark for that. Then I go to sec 2 pi minus b. Sec is 360 degrees minus, 360 degrees minus. Sec and cos are friends, which means sec is going to be positive. Right. Now, cos, it's 180 degrees minus, it's here. But cos here, it's negative. So I must just simply write negative cos of b. All right. That's all that we do. Then from there, obviously, then I'm going to write it there. So I'm going to say sine squared of b. So I write it as sine squared of b. There's nothing I can do to that. But with cosec, I can write it as 1 over sine b. Remember, cosec is the reciprocal of that. Divided by sec, I write as 1 over cos of b times negative cos b. These things cancels out now. Here, one of them cancel out. On top, I'm left with sine of b. At the bottom, that and that cancels out. I'm left with negative 1. So my answer is going to be negative sine b. Okay. And I've got 1 mark for that, 1 mark here, 1 mark there, 1 mark of changing that one, 1 mark for changing that, and 1 mark for the final answer. So already 7 marks on this question. I love this question. You must get it right. If it comes Monday, please make sure that you get this question right. Okay, with the graphs also, very important that we also get this right. Now, you go to your calculator, you put this in, the tangent of x. Some calculator will say g of x, and then you put this in. Then from there, you start at 0, you end at 360. Because you have got a 45, your step should be 45. All right, and that's how you do that. Now, then from there, the calculator will give you those coordinates. For the tan graph, first thing that you need to do, if it's tan of x, if it's an original graph, you go to the 90, you draw dotted lines here. You go to the 270, you draw dotted lines there. Those are asymptotes. That's where the graph it's undefined. The F graph is undefined at 90 and at 270. Then I know at 45 it's 1, so this is the only point that I can draw in there. I know at 135 it's -1, so at 180 it's going to be like this. It's going to be 0. At 135 is there, so I'm going to go there, and my tan graph is there. There's no child without a name, so this child's name is F. Right, then I must draw the second graph with 45. So put it on a calculator. I can put these points in here, right? So remember here, it's not an arrow, there's no arrow. I can put these points here. I can start with a 0, cos 0 minus 45. Then from there it will be 0,707, right? Then cos 45 minus 45 will be 1. Then the other one will be there. Then from there we'll have this point at 135. At 135 it will be at 0, and at 180 it's going to be down here somewhere there, and then at this one it will be there, and we have this point here, then we have it at 0, and then the graph is going to end somewhere there. So those points you can get them by putting them on a calculator. I'm not going to waste time there, so I'm going to draw my graph, and my graph is going to stop there. See, then I have this graph of G. My boys and girls, these graphs, if you draw them correctly, up to 7 marks. You get up to 7 marks. Simple, straightforward. You are having a calculator. No one must not be able to draw the sketch. You must all be able to draw the sketch. If the sketch is given, you must be able to can answer questions from the sketch. Okay, right. Now they say, use your graph to write down these values of x, where f is undefined. I think I've already given you the answer. It's at 90. Again, it's at 270. Right. Here is a challenging question. This question is a bit of a challenge. But if I can read the question and then look at what is happening in the graph. We are saying this graph multiplied by this graph will give us less than 0, meaning that it will give us a negative value. So if I check on my graphs, this is my x-axis. Right, my graph, all my graphs, this f and g, they are above. You see they're above there. That one is above the x-axis, above the x-axis. But from here, this graph is below the x-axis. Can you see? Up to here. So it becomes negative if it's below. If it's above, it is positive. Right. So now we need a graph where the two graphs, if I mark this graph here, it's negative. Can you see? But from here, it's positive. Now I need a graph. I need where the two graphs, the other one is positive, the other one is negative. So if I check here, and they say from 90 to 180. So I'm checking from 90 to 180. If I check here, this graph here is above, this one is below. But from here, the two graphs are below. So which means that from here to there, this part here, the graphs are going to be, the other one will be above, the other one will be below. So which means that it is between 135 degrees, remember this is included, and 90 degrees. Now check, I did not put equal sign on this one. Reason? Because this graph here is an asymptote. There's an asymptote for the f graph, but on the side, on the 135, there's nothing, so that's why I left it. Okay, all right. Now, and this question we always leave it and then we don't do it, and it's quite very easy. Just check where the graph is above, where the graph is below, right? Then from there you can write the plus 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 on top, the negative 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 at the bottom, and then you're able to can do that question. Okay, we are going to take a 2 minutes break, then we'll be back and do the Euclidean geometry. Right, welcome back. Now, Euclidean geometry, we said it's 40 marks, 40 plus minus 3. Now, in Euclidean geometry, remember it will start from question 7. Right. One of the questions that they like in Euclidean geometry is asking you to complete the theorem statements. So you need to know all your theorem statements. Grade 11 ones on the circles and grade 12 ones. Now I've put this 3 here. It says the angle between the tangent to a circle and the chord. So I'm just going to draw a picture of what they're talking about here. So the angle between the tangent and the chord. So if I've got this angle here, that angle equals to that angle there. So it means that it is equals to the angle in the alternate segment. So that's theorem number 9 in grade 11. The angle between the tangent and the chord. So it's tan-chord theorem. Please know your theorem statements. The second one says the angle subtended by the diameter. I'm just going to draw a picture here again. So here's a diameter. The angle subtended by the diameter. Remember, if this is a diameter, this is the center. The angle that is formed there is 90 degrees. So meaning that you can say it's 90 degrees or it's a right angle. Okay. Right. The last one, exterior angle of a cyclic quad. So in other words, you are having a cyclic quad, all 4 points on the circle, and there's an exterior angle here. So that angle will be equal to that angle there in the opposite. Okay, so this angle and that angle will be equal. So it's equal to the opposite interior angle. Please write it in full. Don't do what I'm doing. Okay, so write it in full. So it's opposite interior angles. So this angle, exterior, opposite interior. Okay, right. Practice them. Now here's a question here. It's a very tricky question, but if you understand this, you'll be able to understand the easy ones also. In the diagram, the radius of the smaller circle through P. So in other words, here's a smaller circle. They say the radius of that here, it's going to be how much? 17. The radius of the smaller circle is 17, yes. And they say the radius, remember the radius is the line from the center of the circle to the circle. So it's 17. And the radius of the bigger circle through Q, which is this line here to Q, it's 25. So that radius is 25. Right. They say OM is perpendicular to that, so that is indicated. The length of OM is 15. So can you see this line here is not a radius, but that length here is 15 millimeters. So now I've got two diagrams here, and this angle is 90 degrees. So I'll have this smaller diagram, which has got a hypotenuse and a side. I can get this side. So for me to get PQ, right, for me to get PQ, what should I do? I must first get MP. So MP squared, so this line here will be 17 squared. So you see, we're just dealing with the theorem of Pythagoras here. It's 17 squared minus 15 squared. And MP will be equals to, work it out quickly, so that will be MP, it's equals to the square root of that, which is going to be 8 millimeters. So MP will be 8 millimeters. Now I need MQ. So for MQ, I'm going to use 25 and 15. Can you see? So now I've got this one. I need MQ squared equals 2. So I'll say 25 squared minus 15 squared. And if I work out MQ, square root of that, so it will be square root of 400, which is 20 millimeters. So the length of MQ is 20 millimeters. So how am I going to get the length of PQ? Oh, that's quite easy now. So the length of PQ will be 12. How do I get it? PQ length will be the same as MQ length minus MP length. So which is 20 minus 8, and that will be 12 millimeters. Okay, it's a tricky question, but we're just dealing with theorem of Pythagoras, nothing else, because then we're just looking at that length of that and the length of that, and we are able to can get the length. Okay, so that's 20, and that will be PQ, which is 12 millimeters. All right. Okay, this is 7.2.1, sorry. 0.2. Okay, now here you are given that A, B, C, D is a cyclic quad. So I know that those points are on the circle, so they're cyclic. MK is a tangent, so this whole line MCK is a tangent. And it touches the circle at C. Very, very important information here. CA bisects BCD. So meaning that this angle here and that angle are equal because they are bisected. That angle is bisected. So D2, how am I going to get D2? So I work from the sketch. This is the angle between the tangent and the chord. Can you see? From that theorem statement, you remember? So that angle here will be 50. So this angle will be 50. I must give reason. The reason will be tan chord. That's all you write, tan chord theorem. That's all you write. Alright, you don't write the theorem statement, you just write it. Right, B1, how am I going to get B1 now? B1, I know that angle here, it's also 50 here. It's also 50. Because there's angle in the same segment. So for me to get B1, so I've got 50, I've got 110, so B1 I can get. So B1 can be 20 degrees. The reason will be sum of angles in a triangle. Sum of angles in a triangle. But remember, for me to get B1, I must first get A1. So the statement that A1 will be equals to 50 degrees. And I've got the reason here. Angles in the same segment. All right, so I'll have that. For me to get to B1, I must first get A1. So therefore, I'll get those two angles there. So now I already know that this angle is 50. This angle is 50. This angle is 20. Obviously, if this angle is 20, C3 will be 20. Alright? So for me to get D1, C3 will be 20. If C3 is 20, C2 will also be 20. Because remember, this angle here is bisected. Alright? Okay. So you must read those statements and then from there put that on the sketch. So I already have this one is 20. I need D1. That will be easy now. You see D1 and that will also be that. So D1 will also be 20 degrees. The reason for D1 to be 20 degrees, it's angles in the same segment. Same segment. Okay. Right. So first of all, I must get these two angles. And once I get these two angles, then I'm able to can get to D1. If I don't know what is C2, I'll struggle a bit to get to D1. All right. Right. Now we go to circles, angles, and angular movement. So when you do your Euclidean geometry, please make sure you work on the sketch. And the sketch that you remember you are having an answer book. So in the answer book, you work with the sketch with your colors, and then from there you put angles on the sketch, and then you do your write up on the space provided. Right. Now this one, it's circles, angles, and angular movement. The bottom sprinkler head is set to irrigate only 20%. only a sector which is 20% of the circular garden. 20% of the circular garden. So this is the circular garden. So this part is 20% of the circular garden. Simple to understand. Simple, straightforward English. Calculate this angle here. This angle is 20% of the whole. So how am I going to get it? So I'm going to say 20% of the whole. And what is the whole? 360 degrees, because I need an angle. So this is FOG. So 20% of that will be 72 degrees. Okay, you can take a calculator and say 20 divided by 100 multiplied by 360, you get 72 degrees. They'll give it 1 mark. There's nothing to worry about on that question. 8.2 says the area. Now we need the area of this part. Area. You go to your formula sheet. Where you find the formula for circles, angles, and angular movement, you write down the formula for the area. So the area is equals to r theta over 2. Why am I using r theta? Because I don't have the value of s, which is the arc length. So now I'm going to say my r is going to be, first of all, I must change that angle 72 degrees to radians. So for me to change it, the angle that I want must be at the bottom. So this angle is in radians, is 2 over 3 pi. Now it's in radians. Then I substitute my radius. My radius is how much? 6.95. That's my radius. Multiply by 2 over 3 pi. All divided by 2. Then I just put down there on a calculator. Then I'll get 139 over 100 pi. Or I can write this 4,737. Remember, it's square meters. We're talking to meters. Area, it's square meters. So I must get it as square meters. Okay. Right. Now, then the next part that we need to do is the one on angular velocity and circumferential velocity. A Ferris wheel with a diameter with a radius of 10. So I know I've got a radius. 18 revolutions per hour. But if you look at the question here, it says determine the rotational frequency of the wheel in radians. You see, we are given revolutions, but we need it in radians per second. So which means my n is going to be, I've got 18 revolutions over 1 hour. So it is 18 revolutions per hour, which means over 1 hour. I want to change this to seconds. So it will be 3,600 seconds. So I'll change it by saying times 1 over. But remember, these are revolutions. I want to change them to radians. So I must multiply this by 2 pi radians all over. We know that 2 pi radians is the same as 1 revolution. Revolution is 360, right? Revolutions. So can you see the revolutions and the revolutions will cancel out? The hour and the hour will cancel out. Then I'm left with the radians over the seconds. So my answer there is going to be 1 over 100 pi. Remember, this is radians per second. You see how we've done that, eh? So I want to change it from revolutions to radians, so I can just multiply that by. So now 9.2 says you need a circumferential velocity. Remember the word circumferential, it's this. So I'm going to substitute pi, I don't substitute. Radius, diameter, how much? 10. So this should be how much? 20, right? Then I'm multiplying by n, right? So my answer there, calculator, is 1,97 meters per second. Okay, so remember this is in meters. Then we have seconds on our revolution, radians per second, okay? Right. The last question, which I believe everybody practices this one and every day, and then from there, you know, it's gonna come at the end of the year, but sometimes they ask it very differently, but we need to know all the ways. In this case, they say determine the length of the rectangular carpets. The length here that is given here, we are given the breadth here as 7,5, and I'm also given the area of a rectangular carpet, which is this. So I'm given the area, I'm given the length, and I've given this damaged part. You can see this damaged area. The other part is not damaged. So the length here, it's actually not given. There's a p, but I can write it. I can write it length as 10 plus p. That is my length. The one that has been given, there's the one that has been given there. Okay, now remember this one is 7, so it cannot be, right? So now hence they determine the value of p. So how am I going to get the value of p? I know the area that is given there is the length multiplied by breadth, but the area is given as 187,5. The length is 10 plus p. That is my length here. The breadth is, remember it's multiplied, the breadth is 7,5 meters. Right? Now, to get the value of p, I'll multiply this in, so I'll get 75. It's 7,5 times 10, it's 75, plus, let me remove the m there so that I don't confuse myself here. So it's 75 plus 7,5 p, 187,5. So to solve for p, so I'll have 7,5 p equals to, if I take this one this side and I subtract it, then I'll get, let me just quickly do that. So I'll get 187.5, then minus 75, and the answer that I'll get there is 112,5. Then from there I'll get the value of p. So the value of p, I'll then divide this by 7,5. Then I'll get p equals to 15. So meaning that the length of that will be 15. The length of p, sorry, will be 15. So which means that if I've got p as 15, the length of the whole line there will be 10 plus 15, which is going to be 25. Right. So I have the length there as 25. Then from there I'll have the breadth as 7,5. Now, this question, it's, as I said, they asked it differently this year, that year, so we'll have that length, we have got that. So let's check if we can be able to do the last question quickly. Now, it says it takes, remember this length here, the whole length is 25. The whole length there is 7,5. We've got 1, 2, 3, 4, 5. Which means, for me to get, first I must get the value of a. To get the value of a, I must divide this one by 5. So I'll have 7,5 divided by 5, which gives me 1,5 meters. So the value of a is 1,5. Now, let's read the question. It takes this hours to repair 1 square meter. Calculate the minimum time. And they gave you the hint there. So which means I'll go and calculate the area of T. which is going to be my A. What is my A? 1,5. I'm going to use the second formula, which is O1. So it's going to be my O1, which is 7 plus 12 divided by 2, this first one and the last one, plus 11 plus 18. And then I close, did I miss something? Yes, 15, and then plus 18, close bracket. Then the area that I'm going to get here will be 80,25. Right, that's the area that I'll get. But I'm not done because I need the area of the damaged. So for me to get the area of the damaged, I'll say area of the whole rectangle. I know it is 187.5. Then I'm going to subtract this area here. If I subtract the area of that part here, then I'll get the area of the damaged. Because the area of the rectangle is given. I now know the area of this part here. Then I can just say the area of the damaged will be this minus 80.25. Then once I get that area, I think I'll get 107.25. Then this area is the area of the damaged, right? But they say it takes 0.25 to do that. So I'll say area of that, the time that is going to be taken by that will be 105 times 0.25. And that will be 26.8 hours. Okay, so as I said, they asked it differently, but you must be able to do that. Lastly, I just want to get to the tips quickly. Make sure that you have your materials ready before you begin studying. You know, everything that you need, pencils, pens, calculators, highlighters, calculators, make sure that you have them. Make sure that you're positive, be positive. Make sure that your brain holds onto the information you are learning by reminding yourself how important it is to remember the work and get the marks. That's very important. Take a walk outside. Change of scenario will stimulate your brain. Break up your learning sections into manageable parts. Don't just read, practice, and then from there you must practice and have a manageable parts that you're practicing with. Okay, keep your study sessions short but very effective. Make sure that you reward yourself with short and constructive breaks. Teach a concept to anyone who will listen. In other words, you can work with somebody so that then you are able to can check each other. Your brain learns well with colors and pictures, especially in geometry. Please make sure that you use color. Be confident with your learning areas you know well, and focus on that. Repetition, and practice is the key in retaining the information that you have learned. At least please sleep 8 hours. Because sometimes, you know, you cross night, and then from there you sleep at 3 o'clock, and then from there you get up late. I've seen so many of learners coming late to the examination. It is because they don't sleep enough. Please make sure you sleep enough and drink plenty of water, because that's very, very, very important for your brain. I want to take this opportunity to wish you good luck in the paper on Monday. Just go out there and work out. This weekend, please have a technical mathematics paper 2 festival. Make sure that you understand all the concepts tomorrow and Sunday, and on Monday we'll get better grades in this paper. Thank you so much and good luck.